I look at multiplying polynomials in this video, kind of a little bit of a review, because in the following week we're going to be looking a lot at factoring. So this is kind of the reverse process. So just a quick review. When we talk about polynomials, these are algebraic expressions that sometimes have one term, two terms, three terms, or many terms. But that's really what the name polynomial stands for, is this idea that it's a mathematical expression with many terms. So just a quick review, when we talk about monomials, binomials, trinomials, we're talking about expressions that either have one, two, or three terms respectively. And generally speaking, any algebraic expression, for the most part, a lot of them are considered to be polynomials as long as they have whole exponents that are non-negative and non-real real coefficients. So just before we kind of take a look at some examples here, and I have you go do it on your own, let's review really quickly some vocabulary. So first things first, when we talk about what is a factor, when we talk about mathematical factors here, the first definition we look at is just any number that divides another number evenly. And so for instance here, like the number 24 here, it has factors like 4 and 6, but because when I divide 24 by 6, I get 4, but the remainder is 0. Okay, and the other way to look at it is if I were to take 24 and divide it by 4, I would get 6, but also the remainder would be 0. So that's our first definition of a factor. The second way to look at a factor is just it's a number or an expression that with other factors can be multiplied together to get a new number, and that new number we get usually when we multiply things is referred to as a product, right? So for instance up here we know that 4 and 6 are factors of 24, but because these two factors produce 24 when we multiply them together. So as a quick review, we're going to take a look at 4 quick examples. I'm going to have you do these on your own and submit them. But take a look at letter A up here with me. What we see first is that we have 5x cubed times all of this stuff in the parentheses here. And so I noticed that if we're counting terms as things separated by pluses and minuses, inside the parentheses here, this thing has 3 terms. And really quickly, you'll notice that our exponents go in decreasing order of size here. And so we call that standard form. But it just means that we're taking a one-term thing, or a monomial, times a trinomial here. So we have a monomial times a trinomial. And the way we tend to do this is just simply distribution. Okay, so distribution, that's this idea that we're going to send this monomial through this entire set of parentheses and multiply it by everything. I like to put in these little rainbows here. So let's take a look at what this maybe looks like. Really quickly before we do this, let's recall one of our rules of exponents that says when we multiply things with the same bases, the base stays the same, but we add the exponents. Okay, so that'll be important here. As we look at this first product, we say 5x cubed times negative 2x squared. Remember, we start in front with the coefficients, so 5 times negative 2 is a negative 10. And then x to the third times x to the second, that'd be x to the fifth if we're adding our exponents there, since we're multiplying two things with the same basis. And so just going from left to right here, we would say, okay, well, 5x cubed times 3x is next. 5 times 3 is 15. And then x to the third times x to the first is x to the 3 plus 1 is x to the 4. Okay, and lastly, we would get a negative 7 times 5x cubed. Well, 5 times a negative 7 is a negative 35. And we would just keep the x cubed here. And so you'll notice that this is in standard form, and this would be our product here of these two factors. Taking a look at letter B, I want you to notice something here, that we have a two-term thing times a two-term thing. I'm going to write this up top here. Anytime we take a binomial times a binomial, this is when you hear this acronym FOIL. Okay, and so perhaps we should write it vertically here, F-O-I-L, but just recall that this stands for first, outer, inner, okay, and last terms here. And the way that kind of works is up top here, we're going to multiply our first two terms in each set of parentheses. So x times 3x would be 3x squared. And then we multiply the outer two here. So that would be our outer two. X times 5 is 5x. Let's do our inner two. Negative 4 times a positive 3x is negative 12x. And then we would get a negative 4 times a positive 5 is a negative 20 here. So some things, remembering that when we multiply, it's important to write our product in standard form. I notice, and this happens a lot, that I have a couple of terms here that are both x to the first. And so we can combine like terms, right? And we would get 3x squared. A positive 5 and a negative 12 adds up to be a negative 7. So we'd have negative 7 of these x's to the first, and this would be minus 20. Here would be our standard form product here, this trinomial. So taking a look at letter C, I kind of got this one set up as a couple binomials we can multiply together as well, and so we're still going to FOIL. But I want you to notice something here. In this case, these binomials are almost identical except for this middle sign here. One's a plus, one's a minus. And so recall from our polynomial days that we refer to these as conjugates. But something we're going to see a lot of the time with conjugates, this idea that a plus b times a minus b, is that we always get a difference of 2 squares. So let's take a look at why this happens, how this happens. Let's do our firsts. So first is 2x times 2x, or in other words, 2x squared. We're going to get a 4 and an x squared. And now if we take our 2x times a negative 7, we get negative 14, that's x to the first, But then our inner product here is a positive, and it's the same size, same magnitude, same substance. And so we're going to see that these terms cancel out when we combine like terms. And let's go ahead and finish up with our last here. Negative and positive 7 equals a 7 squared, but it's a negative. So what we end up seeing happening is a product of two conjugates always gives us the 2x squared, the first term squared. A times a is a squared here. And this is always minus because of the difference in the signs here. One's positive 7, one's negative 7, or one's positive b, one's negative b. But we would get minus 49. We can see that this is a difference of two squares in standard form. Okay. So for letter D here, I still want to take the same tactic. We can use distribution here, and I certainly don't have a problem with distribution. Oh, looks like my pen is going crazy here. Let me try to fix this really quickly. That's better. Sometimes that happens. Thanks for being patient with me. Plug this back in. We'll try again here. But I want you to notice in this last one, letter D, that you have a binomial times a trinomial. And so one tactic we've used previously is distribution, whereas we've got to take the 2x times everything over here, and then go back through and take the 7 times everything in here. And that's certainly how I'll start here. 2x times 4x squared is 2 times 4 is 8. And then we get x to the first times x to the second is x to the third. 2x times negative 5x is negative 10x squared. And then 2x times a 3 would be a 6x. Moving on to the 7 times the 4x squared would be a 28x squared. The 7 times the negative 5x would be negative 35x. And then the 7 times the 3 here, this would be a 21. So you can see that there are a lot of terms here that we can combine. I notice that I only have one x cubed term, so 8x cubed, but then I have a couple of x squared terms here. So a negative 10 and a positive 28 here would add up to be a positive 18x squared. 6x to the first and 35x to the first here. A 6 and a negative 35 would be a negative 29, so we're going to put a negative 29x to the first here. And then we get left with this 1, 2, 3, 4, last constant here is 21. So this is really an effective tool, multiplying polynomials this way. The last way I want to take a look at this last one is just anytime you take a binomial times a trinomial or higher, like a trinomial times a trinomial, or just big polynomials, it's often a good method to organize this into a table or matrix. And so I tend to put the longer of the two polynomials up top here, 4x squared minus 5x plus 3, and I kind of spread them out here because what I'm going to do is I'm going to make some columns. And then on the left column here, I'm going to put the 2x and the plus 7 here, and this kind of makes our matrix. This way is a little bit more convenient, I feel like, sometimes, because we can just multiply the row and the column by each other. So 2x and 4x squared, that's our 8x cubed that we had seen previously. 2x times negative 5x is negative 10x squared. And 2x times a 3 is our 6x here. So you can see that we're really committing kind of the same product that we did last time. It's just that it's organized a little bit more cleanly, if you ask me here. So we'll go through and combine like terms. I see that we've got an 8x cubed. Our x's squared here, right? We've got 18 of those, 18 x's squared. How about x's to the first right here? Well, it's still negative 29, x's to the first. And then we have our constant 21. So what I'm going to look for you guys to do is to multiply this set of polynomials together here. I'm going to give this to you, and then you guys can send your work back to me. But I want to check out what you got, and then starting tomorrow, we're going to look at some factoring, okay? Cheers.